Okay, statistical inference. Statistical inference is the process of generalizing the conclusions about a sample to its population. And statistical inference addresses the question whether the phenomenon we observe in the sample is also likely to be real in its population. Or can we rule out the phenomenon we observe is purely due to chance? And remember, statistical inference always ends with a decision, decision making. For example, in hypothesis testing, at the end you need to either reject or accept the null hypothesis. Okay, there are two types of statistical inference. One is called hypothesis testing. As you have learned, hypothesis testing consists of multiple steps. So you need to formulate your null and alternative hypothesis, and they are all about population parameters. The null hypothesis usually something equal to something, no change, no difference, no effect. An alternative hypothesis is another scenario that is different from the null hypothesis. And then you need to select the test statistic, and you compute the test statistic from the data to get the value of the test statistic. And you need to select a type 1 error, the alpha level. The most commonly used is 0.05. And you can use the critical value from the null distribution of the test statistic, compare it to the test statistical value, or you can compute the p-value. And then you need to make a decision whether you reject the null hypothesis or accept the null hypothesis. Okay? So decision making based on p-value or comparing test statistic and critical value. Just remember, hypothesis testing is a process. Consists of multiple steps. And then there's another tool for statistical inference is confidence interval. Now you may remember confidence interval is a method for estimation. But once you have a confidence interval, you can also use it to do statistical inference. So the decision making based on whether the observed value of a parameter falls within or outside the confidence interval. Okay, because we believe the confidence interval captures the true value of the parameter with certain probability. So if the observed value of the parameter falls within that confidence interval, then we think there's no difference, statistically significant difference between the true value and the observed value. Okay, so we turn to accept the null hypothesis in that case. Okay, so there are two types of statistical inference: hypothesis testing and confidence interval. And you should remember, statistical inference always contains errors, and this is the nature of the beast because of the uncertainty in the data. Remember, we're dealing with random events and random variables, so we have uncertainty in the data. We can never be sure, so there's no such thing as 100% certain statistical inference. So if you have 100%, it becomes a law of physics or something, So all the statistical inference are subject to errors we call type 1 error or type 2 error. Okay, from the introductory statistics course, you should have learned, what type 1 error and what type 2 errors are. And of course, you still remember the commonly used hypothesis tests for different hypotheses, such as the t-test, one sample paired two-sample t-test. And you have tests for a binomial proportion. And you have non-parametric tests, such as a Wilcoxon signed rank test, Wilcoxon rank sum test. And you have chi-square test for contingency tables. And you have a hypothesis test for testing whether a correlation, the true correlation is 0 or not, and whether there is a true correlation. And of course, related to ANOVA, you have an F-test in ANOVA to test whether all the groups have equal means. And similarly, you have F-test for linear regression test and the t-test for linear regression. They both test the null hypothesis that the slope of the line equal to 0. Okay, so you should have learned all these commonly used hypothesis tests. And there's so many types of hypothesis tests. You may wonder, so how do I choose, an appropriate statistical test for my data? And that is both science and art. Okay, so here you can see a decision tree, which may be useful or may be helpful, but you really need to practice a lot to become eventually really good at this. I want to tell you that two factors that influence the choice of an appropriate statistical test for your data are study design. You want to think about what is the study design. Was it a paired design, such as pre and post test? Whether the data are correlational. Do you have two groups or more groups, etc.? Okay. So correlated meaning like if you have longitudinal studies, the subjects are measured repeatedly over time, then you need to think of an appropriate test. Okay. Another important factor is the type of data. So whether the variable is continuous, it's nominal, or it's ordinal. So this is also a very important factor for determining which statistical test is appropriate to use for analyzing the data.